Hello guys, so good. I'm so glad to have you back. I'm so happy that you are here again to learn. All right, and this particular video is born out of the need to have a resource or a video that you can actually learn, that actually explain the code in details, what is happening and why you have what you have. So if you have watched my previous videos and I have sometimes be quite fast, not really going too deep, this particular video will go deep into what is really happening. And if you want to gain understanding and be able to write your own code, this is the particular video you need to watch. All right, this is a new series and I'm so happy that we are doing this right now. I'm happy we are doing this right now. So let me go straight into what we have for the day. All right, but before then, please, these are the resources, especially these. Everything you need to start with C. I think I opened it here. All right, so you can just take your time to look through that. All right, you can take your time to look through that, and these are the resources. These are the resources. You need understanding. You need to spend time to look through those ones. So again, take your time to look through these general requirements as you have down here. Okay, your code will be tested with Betty. You have a README file and all that. So take your time to go through all of this. They are important and you need them too. All right. Again, before we get started, what I'm going to do in this particular video is that I will try to run GCC, this War Wearer Westock Pendatic. We are going to use it to test our code. What am I saying? If you look through the task, you ask yourself, you are just beginning and you ask yourself, why all these ones? Why, what am I supposed to do with what is here? All right. First, let me let you know that what is here will help you test your code if you are doing the right thing. All right. So after creating this particular file, okay, this particular file, when you create this, after doing that, then you input this from here, and it's going to test your code to know if you are doing the right thing. All right, that will be true for the others you have here. So we're going to do that, and again I'm going to go outside of here, go to code blocks, and again we're going to run our code here also to test if you are going to get the result. All right, I don't know if you get that. We're going to run our code on both sides to ensure that we get result, not just get result, understand what is happening. That's why I'm doing this video right now. So I believe you understand what I'm talking about. So again, for those who have not done the quiz, this is a quiz, but this video is not for quiz, but you can look through. And again, I think I have a video on this before now, so that will help you. But again, you can look through this to pick the answer, but that is not the aim of this video. The aim of this video is we are going for the bigger cache, guys, to explain how the code works. That is what we are going to do in this particular video. So first things first. All right, first things first. After your resources, then you are going to come here. Okay, you're going to come here and get a sandbox and all that. So we are going to start right away. I believe you are ready. If you are ready, I'm always ready. Let's dive right in. So I'm going to allow me restore this down. Okay, so I'll get a sandbox. I'm going to use WebTem. You can use your git bash. You can use your git bash, but let me do WebTem for this project. All right, so once you do that, you have here, all right, you have this, and the next thing you are going to do, you're going to do cd to ensure you are in the root directory. Do cd root, okay, cd/root, and yes, I'm in the root directory. I'm very sure I'm the root directory. So again, you are going to create this of course, ALS low-level programming. All right, this is a repo on GitHub. All right, of course you should have this repo on GitHub for now. So the next thing you are going to do right now, you are going to cd into this ALS low-level programming. Just copy it from here and paste it. Okay, paste. You hit enter. All right, we are in ALS low level, and the next thing you have to do is to create this directory, 0 times 01 variable if s y. So to create this directory, so what you do, you copy and you come here. You remember how to create directory. You use your mkdir, which stands for make directory. All right, once you put that, you click, you paste this 0 times 01. You can type it out if you want to, but just copy that. If I hit enter, it's going to throw an error because why? I already have that directory. I created that before now. All right, so I'm going to say that cannot create directory because it's already there, guys. It's already there. So if I list now, you see, yes, you have that directory. This is it. It's already there. So if you run mkdir, and you paste this, it's going to work. It's not going to throw an error for you. All right. So once you paste that mk, it's going to create your directory the way it should be, but because I have that, it's going to throw an error. So let's proceed. So since I already have that, I'm going to cd change directory into a variable if s while. So if I paste, I hit enter. All right, I'm in my variable if s y directory. Okay, so since I'm here now, the next thing we are going to do is to start working on the files one after the other. And again, let me say this. Since we are going to be explaining, all right, I want you to pay attention, and peradventure I cannot finish them in this one video. I'm going to have a second part to this video. Peradventure I'm unable to round up, I'm going to have a second part to this video. All right, still doing the same thing, basically giving you understanding and helping you write your own code rather picking other people's code and allow Kimba to flag you up. All right, you really don't want that. So what we are going to do right now is to create a readme file. You understand that we should have a readme file at the root of our directory. So you're going to come here. Okay, let me go so that you see that. Yes, a readme file. All right, a readme file. So let's quickly do that. Let me just expand it. Okay, so I believe you can see this. Do I have to increase? Okay, let me just increase, zoom it a little. All right, I believe this is fine now. Okay, it's fine. Alright, at some point I'll have to expand so that you see it. Okay, so if I do vi readme.md, alright, yes, this is our vi readme. Alright, so once you open this up, it's going to show you a blank page. Okay, then you type in your readme. This is for mine. You don't have to type the same thing. All right, in fact, for the sake of Kimba, you have to type your own readme and make it unique to yourself. Okay, so type your readme file. So once you type that, just make sure it's not empty. You don't have, there's no predefined text for you to put in your README. Customize it to your own taste, all right? Type yours, don't copy what is here. Okay, once you type your README, you do escape, shift, column WQ. What that means is to write that save and quit. All right, so if I hit enter, I'm going to get out of that. That means I've created my readme.md file. I don't know if you understand that. All right, we have created the readme.md file. That is the first requirement for this project. So have we done that? Then we come down here and look through again. I want us to take it one step at a time. Of course, we have to pass petty test and all that. So I'm looking through the requirement with you so that you know what to do at every step. Okay. So I believe that is that. So let's just start taking the project, the files one after the other. So the first one we have here, it said look through. So I'm going to be reading from here. Look at it. Read this. So positive entity is better than negative nothing. This program will assign a random number to the variable n each time it is executed. Complete the source code in order to print whether the number stored in the variable n is positive or negative. You can find the source code here. All right, so it's advisable you click here. Okay, so this is the source code you have to use, and again, these are the header files. I'm going to explain this in a short moment. And again, what you're expecting to do, you have your comment section here, right? This space between more headers and Betty style. Then you have these just remain the same. Where you're supposed to change again will be here. Okay, so that is what you are expected to do. So basically, you are supposed to copy this code and then modify, make some little changes. That is what you are supposed to do here. So having said that, let me go back to the project. Then you don't have to understand what rand. Of course, I'm going to throw a little light on that so that you won't be left in the dark. Then the output of the program should be the number followed by, if the number is greater than 0, is positive. If the number is 0, is negative. If the number is less than 0, is negative. This is 0. If it's 0, it's 0. Followed by a new line. Okay, so that is exactly what we are going to be doing now. That is exactly what we are going to do right now. So let me increase this a little again. See it, it's bolder. All right, so we proceed. We create the file vi. That actually jumped to any other line. Okay, create the file vi, and what is our file name? We come back here. This is it for the first file. I'm going to copy this. That is the file name. I'll copy it. Then I'll come here. I'll paste. Alright. Then, once you do that, you are creating 0 positive or negative.c. So, if I hit enter, alright, I already have that. This should not bother you, alright? I'm just going to recover this and hit enter. Alright. So, that was a swap file. Meanwhile, I'll show you how to go around anytime you have swap files. Okay, so yes, this is it. Let me explain the code right now, like I promised. All right. So you have include stdlibrary.h, include time.h, include standard input output.h. Then you have the comment section, and you have the main program. Okay, first things first, what are we doing here? Why do we have this? Okay, so for this, why are we including standard library.h? Why are we putting standard library.h? In C programming, there are what we call preprocessor directives. Okay, there are what we call preprocessor directives, and these are included in the header files in C programming. They are called what? Preprocessor directives. Preprocessor directives, and they are standard directives used in C programming language, and they are more like library files. Okay, and since they are library files, you link. Once you include them, it means that you want to use a particular function in your program that will need these standard libraries. It means that if I include this standard input standard library.h, I want to use a particular function that will require this, and before I use that function, I have to include this in my program. I don't know if you basically understand that. And for this particular one, for this standard library.h, all right, it includes declaration for standard library functions, like I said earlier, and such standard library function for standard library.h will be, let me just quickly, std lib.h. What are the functions that will make you include it in your program? Such functions include memory allocation, when you want to allocate memory. And how do you allocate memory? Maybe you have not gotten here, you use malloc, and when you are done, you free your memory. So once you are doing this, you need to include standard library.h. Other situations include random numbers. When you want to do some mathematical operations, display random numbers, you include that. So of course you begin to see why we are putting this, and you can see this run here. I'll come to that. That is why we are including standard library. Okay, random number generation and conversion of functions. So that is where we use standard library.h. I believe that is becoming a little clearer. And here, to be specific, we are using, just need to show you this. So why are we including standard library in this particular program? I've given you generally what it does, because we are using this srun function. I believe you're getting it, because we are using this function, all right? This function. That is why we are including standard library.h. It's clear enough, right? All right. So let's move to the next one. So that done, we move here. Why are we including time.h? Time.h again is a preprocessor directive that is used for including this time argument, this time function. Before you add that, you are going to include time.h. Okay, time.h. So this time.h function, what it does is that it returns the correct time. It returns the correct time in seconds. Since the Unix epoch. And what's the unique epoch? That's the unique epoch is January 1st, 1970. Or you don't have to kill yourself about it. You don't have to really, by and by, you will get all of this, all right? But I just need you to understand something, that we add this preprocessor header files, header libraries into our program because we want to use specific functions. I don't know if you get it. So for this runs with this, okay? So this runs with this, okay? Then time.h runs with this. Before you use time.h, time function, you have to include the directive. It has to be there. Without this time function cannot work. I don't know if you get it, right? Then again, we used another preprocessor directive or a library or a C library called standard input output.h. So why do we use, why are we including this? Why are we including this? What function is this preprocessor directive linked to, right? What function is it linked to? I believe you can see printf here. Printf function, this standard input output.h is linked to printf function. This, so more like I use printf, I have to state the preprocessor directive that controls that. I think there are about 3 of them, 1, 2, 3 printf. So that is that. So I believe you understand that, why we did this, why we used what we used, and basically that is that. So again, let me throw more light on standard input output .h. std input output.h. Let me throw more light on that. For std input output.h, the header file is included include the standard input output library in C programs. So standard input output libraries in C programs. So what particular functions require that library? You have the printf function, you have the scanf function, you have the get character function, put char, or put car, however you want to call it. So before you use some of these functions and others in your program, you have to include, you are including what? You have to include standard input output.h. Sorry about this. You have to include standard input output.h. I believe it's a little clear now, right? Right? I believe. Of course, if you have further questions, drop them in the comment section to these videos. Okay? To this video. Alright. So look through. It's a little clearer before now. So let me clear here. Becoming messy. Alright. So that is why we are doing this. Okay? So I believe for this I have been able to explain why you have all of this. Okay? So as a beginner to the C programming language, this is a guide you need to scale through this. So let's come to the comment section. This is the comment section of this program. Comment section. Comment section, which is this. What we have here is called comments. This is how you add comment to your program in C. And for this particular program you are in, you need to always add comment to your program, and it's a good you have to learn that now. All right, it's a good programming techniques to always do that. So for this, you have main and return. What are they doing here? Why are we adding this main specifically to this? Okay, if you look closely, you have a function here, and it is called main. All right, you have a function here called main. Since you declared this function, you declared this function in your comments, you have to state that this is the function name I use, called what? Main. I don't know if you get that I use the function name called what? Main. All right, and you have to give a little breakdown or a little explanation of, or write or a little comment about it. So here I have entry point. All right, entry point. Of course, I'm taking my time because this is the first one, and I need to explain a lot of stuff because you are just entering this. This is your beginning level in C programming. I believe you may be new to C programming language, so I need to explain all of this. I might not have to take so much time in the next 5 we'll be creating. All right. So because I use this function, all right, then I have to state through a little more line. So what is main? Main is the entry point to your program. Main is your program entry what? Point. So in every C programming language, you have an entry point. All right, you have an entry point where execution of the program starts, and that here is called what? Main. All right. Then you're having having something here again. You may want to ask, what is this doing here? Okay, what is this doing here? For this is int, and the full meaning of that is what? Integer. Okay, integer. An integer is a data type in C programming language, right? It's a data type. So before you declare a function, you have to also tell us the data type of that function. All right, so data types, you want to know more about that, and data types, let me just put this, data types. So what are they? You have integers, you have characters, short form char, all right. Then you have void. Sorry, I beg your pardon. You have integer, character, string. Okay, string. Then which other one do you know? You can, of course, read more on data types. On data types, you can read more on data types. All right. This is just a brief intro. That in data type you have to state the data type before you include. While writing your function, you have to also state the data type. Okay. Let me stop there for now. Maybe later I'll throw more light on that. Then you have void here. What is this void doing here? Here, this is supposed to be where your parameters. If you have a function name, then data type, This simply means that this function will return a data type called an integer. It cannot return a character, it cannot return a string. It's going to only return what? An integer. And you specifically told the system, the machine, that this is what I want. I want to return an integer. I believe you understand that. Then you have void. This void is supposed to be the space where you enter your parameters, your argument for this function argument. And again, I'm saying that void, it means that I am not going to pass any argument to this function. I don't have any argument I'm passing into this function. And what other way can you write this? All right? This is correct, very correct. But I can also declare that function. I have int main, then I'll just do this. All right? Both this and what you have here, they are correct. Okay? This also shows that my function has no argument. It's void. So you can also type it out void. They are both correct. All right? So having said that, let us dive right into here the program. So having done this, we have to write a program that prints random numbers, right? So having done this, here we declare our variable declaration. We declare our variable as what? N. So this is an integer variable and we call it what? N. All right? Declare it as N. Okay? Then having done that, then we now proceeded to use this function. I told you that srun, this is a directive. Before you use this function random srun, you have to include standard library. I already said that, right? So what does this line do really? What does this line do? We are passing this time as an argument to this srun. All right? And what that does is that, let me explain that here. What that does is that, okay, just hold on. I want to really break this down so that in the next one, you have less questions. Believe me, what that does is that we want to ensure that the random numbers generator is seeded or entered into with a different value, each time the program runs. I don't know if you understand that each time this program runs is going to enter a different value, more like enter a different value for each time the program runs. All right? So that is what that does. And you have here, we declared a variable called an integer variable called n. And once we randomize this number, right, whatever value we get from it, we are going to give it to n, store it in n. That is what we have here. Whatever value we get from there, we will store it in what? N. All right. Then, after that, after that we have this condition. Then we have to give a condition. We used an if-else statement here. If-else statement, if-else statement. That is what we use here. So what is the condition? That if n is greater than 0, printf. I told you that standard input.output.h is the preprocessor directive controlling your printf function. All right. Before you can use your printf function, you have to declare or enter your standard input.output.h. You have to include this as a standard library. Okay. So if n is greater than 0, printf, then what do we have here? Okay, let me do another explanation on this. All right. Here you are seeing quotation mark, more like a percentage sign, and D is positive and all that. So this one on red, what is it doing there? This is called, let me type it. This is called a format specifier. All right. That percentage D is called what? Format specifier. What it does is to specify the kind of format I want to print. You use printf to print, output. All right. So this percentage D is specify the kind of format I want to print. Okay, I want to display. All right, that is what that is doing. Percentage D is not the only format specifier. You have others such as percentage S to print string values. All right. Then you have percentage P and others. There are so many of them, format specifier. So what we are doing here, we are specifying that we want to print an integer value or a decimal integer. That is why we are using this percentage D to let our machine know that we want to print out a decimal integer value. So you indicate it here. So once you indicate that it's positive, that's part of the requirement given us here. It's positive. Then what is this one doing here? A new line. You are telling this slash n. You want to print. After printing, then it should enter a new line. All right. That is what this is doing. New line. After printing, move to a new line. All right. Then give me the value that was randomized here, calculated here, output that value. So basically that is what all of this is doing. So you have if n is greater than 0, printf this. If s if n is exactly 0, printf percentage D is 0, then give me the value here. All right. Then s printf percentage D is negative. If it is not positive 0, then it's negative. Give me the value. Then return 0. So what is return doing here? Return is just stating that the statement indicates that the program has successfully be executed. All right. Return because you are going to see it. Let me just write something about that, because I might not do that again after now. You are going to see it throughout in your C programming. So the return statement indicates return statement. Let's just type statement indicates the program have been successfully executed. All right. So that is basically what you have here. All right. I believe that is basically a little clearer, though but again, this is the first file. All right. We have created the first file. Needed to really break it down so that you understand it. Any further questions should go to the comment section. Okay. So basically, this is what you have. This is what you have. All right. With this, you are gaining understanding of what is happening. Okay. So let me clear this. So you have this. This is what you have as your file, and I've explained this. Okay. So have you done that? You tap your escape column WQ, you save and quit. All right. Just hold on, let me. All right. Column save and quit. W to save, write. More like it's called write, but what it's doing is saving. Then Q to quit. All right. Haven't done this successfully. Then after this, I'm going to give you alternative ways to write this particular file, this program that prints a random number. This is not just the only way. This is just this if-else statement program that we assign a random number to a variable called n each time it is executed. And again, know that here you are restricted to only using n. More like they already gave you you are be given. Thought I opened that up. Okay, I thought I had that. Maybe not. Yes, this is it. They gave you a prototype. You know, you have n there, so you are not supposed to change that variable. N, you have to use n. You have to use n. And again, they want you to also use these other ones. Oh, sorry. So basically, they said, please do not touch this code. It means what we gave you here, just modify it where we want you to modify it. All right. And where do they want you to modify? Here. They want you to modify here. Just put your own comments. And again, where you have your code goes there. So that is where you're supposed to do your little modification, basically. All right. So this once you have this we did this using if-else statement. All right. So how do you know that okay this is working? So let's save and quit first. If I do that, all right, I'm out now. Okay. They gave you your test files to test if what you did is correct. If what you did is correct. So how do you test with these test files? After doing the correct thing, and again I said I'm going to give you alternative code that does the same thing. All right. After doing this, you come here, you copy this, what you have here from GCC here. You copy this. Okay, this is what you copy. Once you copy this, you come here, you paste it in. We want to test if what we did is actually correct. Okay, once you paste it, then you hit enter. All right. If it runs without giving you any error, it means that okay, your code have been compiled. It's called compilation. Compiled it to an executable file. All right, an executable file. I'll show you in a bit. But if I list now, you see these two. This is what we compiled now. So don't look too deep into the others. All right, it has been compiled into an executable file. So how do you now show what is inside? You see this other one, you type this, or you type or copy it and come back here. Once you paste, you hit enter. So you can see that he's generating a number minus this is negative. See, they got this here. If you type that again, paste that same thing. Okay, sorry, that is for the negative. All right, you see, it generated a positive number this time. The first one generated a negative number. The second one generated a positive number. Okay, if I type it in again, it's going to generate something else. Let's see. All right, see, it generates. So our program is going to randomly generate a figure and tell us if it is positive or negative. All right, that is not the only way to write this code. I promise you, I'm going to go to code blocks. All right, so that same program I have here, just give me a few seconds. Let me open it up for you. For you, I did all of this just for you, for your learning pleasure. All right, so you see, that same program is here. So I'm going to run this. This is not a requirement, but if you want to, you can install code blocks on your system and also know how things work here. All right, but it's not a requirement. Okay, so if I have that same program we had just now, using if-else. So this here, if I build and run, all right, so you see, this is negative. I go out again, I build and run, this is negative. Build and run. All right, so it generates random numbers. That's what the program does. All right, then I have another version of the same program, but we are not, we didn't use if-else statement here. And again, this line is a little different from what is there. All right, okay, but here we used switch case. We use the switch cases here. All right, so you have switch n case minus. So what we have here is to switch the cases. Okay, so if case n, if this, we switch when case n is -1 and we print %d is negative n, then we have a break here, then case 0, printf. So why do I have this? I'm telling you, I'm bringing this in just to let you know that there are different methods to to writing these things. It's not just a one-way thing. There are different ways to actually write your code. But why you have to be careful of this, because they already gave you a prototype to work with, okay? And you have to work with that prototype. That prototype I showed you earlier. All right, you have to work with that for you to, you have to find the source code here and work with that source code. Okay, so I believe basically this first file, we have done justice to this. Are you still following? Let's continue. There is more to learn here. There is more to learn. Let's continue. Meanwhile, you can like and subscribe to this channel, because in this new series we are going to be explaining each lines of code, basically giving a deep dive into what is happening. So we go to the second one. Right, we are here now. The last digit. This program will assign a random number to the variable n each time it is executed. Complete the source code. Is that what we have? Okay, yes. This program will have that. Then complete the source code in order to print the last digit of the number stored in the variable what? N. Okay. And again here, they gave us a source code to work with, and the variable n will store a different value every time you run this program. Take note, you don't have to understand. Of course, we've explained some of these, and please do not touch this code. The output of the program should be the string last digit followed by a new line, followed by the string is followed by, if the last digit of n is greater than 5, the string is that, and just read this off, followed by a new line at the end of the day. So just look through this, read it, and basically understand what is expected or required of you. So once again, you open that up. Let me close this, we're done with this. So this second one, they want us to, so this is what they gave you, okay? This is what they gave you, and they want you to put in your code here. Basically, the header goes there, okay? Then Betty style dog for function goes here, okay? Then your code goes here. So these are the places they want you to make some modifications. All right. So having said that, we move here, we create that file, vi, and what is the file name? You come here, they gave you the file name to create with. Just copy one last digit of C. Okay, copy that, paste, using vi, one last digit. So I hit enter. All right. So this is my code basically. This is my code basically. So if you look at that, I've explained all of this in the file we created earlier, but if you look at the version they gave us, you discover that they had standard library.h. Why? We already explained, because they used this. They used srand, which randomized a number each time it is being printed. Then they use time.h. already explained that. So the last one you have to include is what? Standard input output.h, that will help you to print out this. That will help you to print out what you have here. So basically, this is what we have. This is our header files. All right. What you just need to do, include stdio.h to what they gave you here. They gave you stdilive.h, which controls srand. You already have include time.h, which controls this time function. Then we already then you have to add stdio.h, which is going to control what? The printf as a pre-processing directive for the printf function that you want to use. That explains that. And again, this is our program entry point. This is the comment session right now. So this is what you add your comment, then return. You add your return, and this of course is a comment. And take note, you must not write this. You can say return 0, right? Return 0. Can come here and do return 0. So you have to learn to have your unique code. So you can come, you have return for Betty's sake, please learn to have your unique code. Return 0. It's valid, it's going to work. Or you can say return each time 0. It's going to work, right? So you mustn't use specifically what you see here for Kimba's sake and for your sake too. So again, we said this is the function declaration. You have a main function that is returning an integer value data type, and there are no parameters or argument passed into the function. Okay, then here, all right, so this one is here. What I did, I declared two variables. I declared two variables of type integers. Both of them are of type integers. This is variable n and variable m. You must not use n and okay, you can use n. You must use n because they gave you n, but you must not use m. Change m to a, change m to b, change m to c, d, e. Any variable you want to, or any alphabet you choose, you can change m to that. But they gave you n, so you have to use the one they gave you here. But you can modify m. Then you have srun, which of course they gave you here. It's here. It was given here. So then you have n. Of course, it's more like similar to what we did before. That randomize a number and the value is going to be stored in the variable n. Then here you have variable m. You take whatever random value that has been created in n, then you are going to look for the modulus. All right, you are going to look for the modulus. If you divide, how do you do that? Take for instance n is, let me do this. Take for instance n is equals to 25. Then how do you get m? M will be, m will be 25 modulus. All right, so that will be 25. I wrote 20, sorry. 25 divided by what? 10. Modulus of 10 divided by 10. That will give you what? 25. Of course, 25 divided by 10 will be 2, remainder 5. So the value of that will be what? 2. Remainder 5. So here, what you are going to put in m will be 5. Because yes, the value of that will be what? 5 because you are going to use modulus, means you are going to use the remainder. So that is just an example of what you are storing in M. Okay, what you are storing in M. So if M is greater than 5, printf last digit of, you remember what I call this percentage D? Can you remember that? Can you guess? Format specifier. I believe you remember format specifier. It means that what we are printing now is a decimal integer. All right, the value we want to print is a decimal integer. So last digit of this is format specifier and is greater than 5. Then print in a new line. All right, so new line, remember what I said about printing a new line. Enter a new line, then print n, the value of n, and the value of what? M. And if m is exactly 0, printf last digit of this is percentage D and is 0 in a new line. Print the value of n, m. Again, if you have a third if m is less than 6, what this does is, if m is less than 6 and this is a logical operator, this and this double and is a logical what? Operator. Okay. Alright. So that is a logical operator. So what we are saying here, if m is less than 6 and it means and, stands for what? And, right? A logical operator. If m is less than 6 and m is not 0, that is what he's saying here. If m is less than 6 and m is not 0, printf. So anytime m is less than, it is giving two conditions here. If m is less than 6, but it is not going to be 0, printf last digit of percentage D is present and is less than what? 6, and return, sorry, and is less than 6 and not 0. Give me the value of n and m. Then return 0. Remember what I said about return 0? This statement shows that the program have successfully run or have been executed successfully. All right, have been executed successfully. So do you understand what we have said so far? I believe you understand that. Again, here we use the if statement. Of course, this is again not the only way to do this, right? This is not the only way to run this program. There are alternative methods you can achieve the same results. All right. So once you are done, you put in your file. Take note, you must not write exactly same thing that is here. Okay. I'll show you alternative method you can do this. So once you are done, you can do your escape, colon, WQ. It has to be in lowercase. Save and create, and you exit. All right. So let me quickly show you before I come back. Alternative ways you can do that. This is what we have earlier. This is what we have earlier. So you can come to code blocks. If I build and run, so you see last digit of this is minus, of this is minus 7 and it's less than 6 and not 0. So if I leave here again, I build the same code, I build and run again, last digit of this is minus less than 6 and not 0. Okay, so we print a random number each time you run it. Okay, so again, let's see another way you can do the same, achieve the same result. Okay, this is another way you can achieve the same result. All right, another way you can achieve the same result using the same using if-else statement. You can achieve the same result using if-else what statement. All right, so you can, of course, you can use this. All right, I'll try and compile this other alternative method in a file. I'll have to do that and share the link so that you can access those files. All right, this is an alternative method that does the same thing. Okay, so let me build and run this. So look through it. Let me build and run. So last digit of 10 is 0 and is 0. If I leave here again, I build and run. Last digit of 39 is 9 and is greater than what? 5. So it tells us the last digit and state if it is greater than that or that. You know, build and run. Last digit of 88 is 8 and is greater than what? 5. So basically that is what is happening. That is what is happening. So I believe you understand that. So let's hit back. Again, like we have said earlier, you can test these other stuff here to test your code if you did the right thing. Okay, so let's try using them. So you just come here, copy like I explained from GCC here, come and put it here. So if you hit enter, it's going to compile that an executable file. So if it didn't show error, that means it compiled successfully. So after compilation, copy this. Please take note of what I copied and paste. If I hit enter, so you see last digit of this number, what's the last digit? That's 8 and is greater than 5. If I put that in again, you see it will generate another random number. Last digit of this is what? Is 8 and is greater than 5. So that is basically what that program does. I believe that you understand that. It's a little clearer. You have a clearer knowledge of what we have, of what we are doing before you watch this video. I believe it's helping out. So let's go to the next file. Let's go to the next file. toprint_alphabet.c. So what are we doing here? This one says write a program that prints the alphabet in lowercase followed by a new line. That prints alphabet in lowercase followed, but they gave you condition. You can only use the putchar function. Every other function such as printf, puts, etc. is what? Is forbidden. You're only meant to use putchar function or putchar function. All your code should be in the main function. Okay? You can only use putchar or putchar function twice in your code. So 1, no printf, no puts. Only use putchar. All your code should be in the main function. So you should declare a function, call it main, and that is where your program should be in, within main function. Then you can only use putchar twice. I keep saying putchar, anyone. Alright, so let's copy the file name. Let's copy the file name. So at the end of the day, what do they want us to achieve? Again, look at these test files. They want us to print a program, to write a program that prints the alphabet in lowercase. And if you display it, the output will be this. Can you see this A to Z? That is what we want to achieve in this what? Program we want to write. So I copy this. I come here, I paste, we have to do vi, then I paste. If I hit enter, it takes me. So this is what I did before. Now I already have this. Okay, already have this. If you notice here, we are not, if you notice, we are not putting in time.h. No time.h, no stand in. I'm talking about the standard header files. No time.h, no, we're not including stdlib.h that we did in the first and second files. Can you guess why? Yes, I can hear you. Can you guess why? All right, you guessed rightly, because we did not use the random function that we used earlier. You know, we used the random function in the first two files. That is why we included stdlib.h. And again, why are we not including standard? One, we're not including time.h. I believe your guess is as good as mine, because we did not use the time function. So you should know how these things work. All right, so here we only included the standard input output.h. Why? Because we are using the putchar function, putchar function, or putchar, whatever it is. So we are using the putchar function, so that is why we are adding standard input output.h. Know that the function, like I said earlier, like I said earlier, the standard stdio.h is stand for standard input output.h, is a preprocessor directive that help you. It's a standard library for the functions printf. So whether you use printf or you use putchar, the library that controls those functions is the standard input output.h library. So putchar, then what else? We mentioned them earlier. I don't know if you can remember. We mentioned them earlier. All right, and others. All right, printf, putchar, gets, and what? Puts. They make use of this header file, standard input output.h. Make use of that header file. So I believe you understand why we are doing what we are doing, not just coming to copy and you don't know what is happening and you are just going. So that is why I am explaining it in detail, so that you understand why you have what you have. And if at any point you miss out, please play back the video, watch it back and understand what is happening, because understanding is basic. You might not see it now, but later on you will understand why you need understanding. Okay, so that is basically what we have. So again, we declare a function, call it main, like they asked us to do. You see here, main. So main, then this function will return an integer. It's an integer function. It will return an integer, and we don't want to pass any parameters to the function. Like I said earlier, this void. Again, you can write this void like this. Again, you can write it like this, int main void. You leave it empty. So if you leave it empty, it means that no argument, no parameters should be passed into the function. So here you declare what? A character variable. So we declare C as a variable, and is a character, want it to be a character, not an integer this time. So we declare a character variable called C. Alright, then we come here, we initialize variable declaration. That's what this is called. Let me put that rightly. So here you declare your variable declaration. This is variable declaration. All right, then this other side, you assign a value to your variable. So basically we will call this variable assignment. Alright, we are assigning a value to our variable, and again then we give it a condition. We are using the while loop. We are using the while loop. So what is the condition for this program? The condition is that, so we have created a variable called what? C, and it is a character variable, and we initialize that variable to be what? A. We assign A to that variable, the character A. You can see the quotation mark. All right, this shows this a character. Then we gave it a condition. What condition is that? That C, if C less than or equal to Z, the character Z, that if C is less than or equal to the character Z, put char. Put char means we want to put C. That's, we are in the value, we initialize C as what? A. So if in as much as C is less than or equal to Z, so it will, once this program runs, it iterates, and if it finds that the value, the C is A, so it start printing from A, it go to the next alphabet, which is what? B. It prints, so it keep printing. So put char C, A will come out. It will print A. Then it will check, is C, is the value of C now less than or equal to Z? Okay, it's not Z yet. So it come here, C++. It will print the next value, which is what? B. It keep printing C. So in as much as the value is not equal to Z, it will keep till it get to what? Z. So once it gets to Z, you see that the value of C, which is the initial value A, is equal to Z, it stops. So the program terminates. So that is that. Then put char, do this in a new line. Put this in a new line. This is what this is, like I explained earlier, and return 0. So if we say return 0, it means that our program have run successfully. Then you have a closing curly braces, or curly braces, or yeah, a closing curly brace. So that is what is happening here. That is what is happening. So what this does, it will print the character starting with A, go to the next, print. C++ means increment. All right, this is increment. Increment C. That is what is happening. Increment C. So basically, this will print A to Z. So have we done that? Column. Column. You save and you quit. You exit that file. All right. You save and quit. Exit that file. And the next thing you should do, okay, very importantly, let me show you alternative method. Let's go to code block and see Alright, I think this is it. Okay, this is the first one we have there, the one I showed you just now that used while loop. So let me build and run this, then I'll show you alternative ways you can achieve the same thing, exact same thing. So build and run, you see, it's going to print A to Z. Alright, A to Z, that is what this program does. So what other ways? Is this the only way to run this? You can use other ways. It's not just a one-way thing. You can call, I wrote another program that uses the for loop. You can see this. It uses for loop. I actually prefer it because it's shorter. For C, alright? It initialized, it declared C inside the loop, alright, inside the for loop, it declared this C, and inside the same loop, it initialized the value of C to be A. Then inside the same loop, it gave us the condition as long as C is less than or equal to Z, then increment the value of C. Okay, so inside this, so I actually love the for loop because it's easier to shorter code. And so inside that for loop, we did 3 things. We did variable declaration, and what variable did we declare? We declared C. Alright, we declared the C variable. Okay, we declared C. Alright, then inside the same for loop, we assigned a value, variable assignment. Use the assignment operator, which is equal to assign the value to C, and we called it A. Then we gave a conditional statement. That as long as C is less than or equal to Z, then we increment value of C. I actually love the for loop so much because it just gives you almost what you need in the same bracket, in the same parenthesis. But I just use while loop. Alright, so then you have the put. So once you've done this, they put char C. Then once you've done this, then you also put char in a new line, which is very important. Display this in a new line. Leave that as part of the condition. And once you've done this, they return 0. What does that do? Show that this program has successfully executed. You know, the only thing you just need to add to this code is your what is it called? Your comments. And that's very simple. Just come there, put your here after the header file. You just come here, give a multi-line comment. You want to write a multi-line comment. You do this, then it will come down, display this for you. You write main program entry point. You can write whatever you want to write. Program for entry. You do this, then you go to the next line. This should print out automatically that asterisk. comment, right? So that is that. You put this comment, then once you are done, close this up. And that's it. Add this comment to it. So that is basically what you are expected to do here. Alright? So I believe that this has been of help. So let me clear here too. Yes. And again, you must not use C. They did specify anywhere that you should use C. So you can change that variable we declared to A, M, T, any alphabet of your choice. You can change it to that, and you run your program, right? So what they just want you to do is to use putchar. So I have tested the program in code block. So let's see. Let's test with their own file. So to test with what they gave us here, you just copy this, and you come back here, you put that in. From GCC, please always copy the right thing. Yes, it has compiled, then successfully, right? Compile successfully, then you copy this too, and you paste. If you hit enter, you see it has printed out the letters. Alright, there is it. Printed out the letters. So if you did this, to give you that correct answer, of course. So like similar to what we have here. Alright. So I believe that you are gaining, apart from looking through what we are doing, you are gaining basic understanding. That is why I'm doing this new series. It's all about understanding, alright? That you understand what is happening, why we have what we have, why we are doing what we are doing. Okay? That is why, that is what this new series is for, alright? That is why, what this new series is all about, okay? So basically, so we move to the next one. Like I said, at a point, if it becomes too long, I'll end it and I'll do another part to this video, because explanation always take a lot of time, like you are saying it, right? So we move to the next one, which is this 3 alphabet.c. So I'll copy this, and the question is, write a program that prints the alphabet in lowercase and then in uppercase, followed by a new line. So at the end of the day, you see why we use, okay, you can only use putchar function. Every other function is forbidden. Okay, so at the end of the day, you can see after the program, we will write something like putchar and alright. Why? Because of this. Say followed by a new line. That is why we do this. So always followed by a new line, right? So basically, always understand what is happening. Understand what is happening, and of course you can write yours. All your code should be in the main function. You can only use putchar 3 times in your code. So let us do that. So you come here, you pick the file name, come back, do vi, paste the file name. If I hit enter, it's going to display what I have. Alright, you must not put this in your code. Alright, so We have, of course, you should know why we are including standard input output notation why we don't have standard standard include time.h, right? Include library.h, because they are not used in this program. We only used put char. That is why we include the standard input output.h. Basically, then your main is this is the comment section, multi-line comment, main program entry point, return 0. You must not write the same thing. Return 0 is valid. Return success 0 is valid. Right? Always have a way of changing your code. Okay. Then you have the function main to return argument void. Alright? To return void argument. Then here we declare two variables of type what? Character. So we declare two variables of type character. Alright? And we used a while loop here. We used a while loop. Okay? We used a while loop. Before I continue, of course, you should know that, like I've been saying, there are other ways you can do these things. There are other ways you can do these things. We are here. Okay. Again, see, you can use for loop. All right, for loop. They actually used a for loop here, and they declared just one variable, and it did the magic. All right, just one variable, and it did that. Okay, so let me go back. So here we declare this, and after variable declaration we initialize C to be small a character, then D to be uppercase A. We are putting this to show that it is what character. That's why we are putting this what is it called? This inverted command, whatever it's called, that's how we are putting. So we gave a condition here. Y C is less than or equal to Z, put char C. Then if it is less, then keep incrementing until C is equal to what? Z, right? Keep incrementing until C equals what? Until C equals Z. Okay? As long as C is not equal to Z, then keep incrementing this. Keep incrementing. Alright? So, what is another way? We can actually do this program by saying we can write talking about starting from here now, we can write char C. Then once we declare C, we initialize it immediately to A. Alright, we initialize it. Then we can use the same while but in a different form. YC is less than or equal to Z. Alright, follow through, giving you other ways you can write yours. Then we use the OR, which is a logical operator. That means OR C is less than or equal to capital uppercase Z, after you given the condition yc is less than or equal to lowercase z, or c is less than or equal to uppercase z. That is the first condition. So what will you do? You want the program to, let me write it here. After that you have curly brace, then you have put car, put char, put char c, right? So basically put char c, then come down, increment c++. So you can also have this. Then after this you can do if another condition, if c is less than, if c is greater than put c, if c is greater than z lowercase, then you have your curly brace and you have put c. All right, then increment c, c++. Let me c++. Okay, so I will show you other alternatives. I'm just trying to let you know that there are other ways. I didn't actually finish this. I'm going to show you in the code block. I have other alternative code, all right, to do this, just to show you that you can actually do this in another way. All right, so let me see what you have here. So if you come here, okay, this is the for. Yes, this is the for loop. For you initialize I, therefore I equals 0, and as long this is equal, you variable, you declared I, variable declaration, then you initialize I to be 0, and you give your condition as long as I is less than 26. Why are we using 26? Because the alphabets, they are 26 in number, unlike we are using ANSI values. I'll let you know what that means later on. ANSI values, then increment I++. Then you come here, you now say put char A, which is the first alphabet, lowercase a plus I, the variable I. So if it prints a plus I, and we said I is 0, from 0 1, so what we are doing here, we are actually using ANSI values. All right, ANSI values. I think that's the spelling, right? ANSI values. Okay, that is what we are using here. So if we do that, then put char a plus I. Then it comes here again for the same, it just initialize one initialize one variable, which is I. Then here for I equals 0, and as long as I is less than 26, I plus plus increment. So put char, if this condition is true, put char uppercase A plus I, then increment I plus plus, put char new line. So this is another way to run this program. I think there is another way, yet another way. Let me. Okay, this is while, the while loop. All right. Yes, I actually started with this initially. So this is another way to run this, right? And this is quite simple to understand. You declare variable declaration, then you initialize A to C, store it in C, then you give your condition. As long as C is less than or equal to Z, iterate, or C lowercase z, or C is less than or equal to uppercase Z, put char C. So this will iterate and print the value of C. So after it loops through, it will print C. Then if it go back, check is the value of C less than or equal to Z. If it is not, it print the next letter, just like that. So C++ increment. And the second condition, if C is greater than Z, C equals what? Uppercase E, A. So print this new line. This program, let's try this. Build and run. So you see, the problem with this is that it keeps printing. It keeps printing because we did not have this loop. It will keep looping until the program crashes because we did not end the loop. All right. So let me stop that. It keeps looping and looping and looping. Okay. So basically, if we run this, so then you have this. So let us quickly escape colon WQ. All right. So let's quickly test this.